This video tutorial will look at the practical element of creating a break-even chart. This is something that some students really find difficult, and so I just want to show you how to create it. Now we can look at mythical product X. And on screen now you've got some information about that product. We can see the selling price is £4 per unit, the variable cost of producing each one, so the cost incurred in making each individual product X, is £1.50, and our fixed costs are £6,000. This is all the information we actually need to produce our break-even chart. To help us as we carry on, I'm actually going to create some notes at the side of the page. This is optional and really just for your benefit to actually record some of this information because it won't always be in shot. So our selling price, which will abbreviate to SP, is £4 per unit. We have a variable cost as demonstrated of £1.50 per unit and a fixed cost of £6,000, and obviously that's over a period of time which we're calling a month. Now on our chart here we have two axes already. We have our x-axis along the bottom, which is going to be showing our level of output, and certainly in simple break-even we're looking at today, we're just going to assume that all items produced are sold, so output and sales are essentially the same thing. And we're measuring this output in units. Our y-axis up the side will be showing the value of these transactions in thousands of pounds. I'll include the unit here. So we're actually going to be showing our revenues and our costs on that same graph. So we're not going to call it on the y-axis costs or revenue, but value, because that's what's going to be the monetary value of those. Now a lot of students struggle to know where to actually start with their graphs, and actually beyond the actual design of our value against output, how to lay this out. Now you can do this as a portrait view, you can do this as landscape. I prefer landscape. I find it gets a little easier. If you do it portrait, it seems to end up being a bit squashed. Again, it's personal preference, both are relevant and both are fine. Now in terms of the numbers you're going to use, where do these scales go from? Well, we always start at the origin with both being 0, so I've already marked that on here. Now our value in thousands of pounds, we need to know what the highest figure is, and you'll find this being our total revenue at our highest level of output. Now for this business, their maximum output, or certainly what they anticipate selling, is 3,500. I've graphed to 4,000, so therefore you can see our total revenue at output of 4,000 is going to be £16,000. So that's going to be the top of my chart. So I'm actually going to have £16,000 up here. Now I've actually pre-measured this just to speed up our video and know this fits. Our level of output could be the maximum they've offered, but if the question was to ask us what would happen if we increase production, etc., we might want to know a little bit more. So I've actually allocated and allowed to actually have our output at the bottom going to 4,000 units. Very quickly, I'm just going to mark those in so you can actually see what this now looks like. So here we have our fully marked up axes. Again, I pre-prepared mine just to make sure I could get it to fit and to make it as large as possible on the page for you to see. The key thing is, always try and make these as big as you can on the paper provided for you. I've blown this up to A3, you might be using A4. Try and make the best use of space. Again, one of the limitations of doing break-even with a graph, certainly by hand, is the accuracy, certainly if you're dealing with quite significant and large numbers. We have, between the two areas here, 500 units of output, so therefore a small movement of where my line goes is actually going to be quite significant in terms of that level of output. So the larger we can make it, hopefully the more accurate it will be. On that note, it's important to think about how big the increments are along our x and our y axis. So in our notes at the side, I'm just going to keep a record of this. On our x axis, you can see between our major scale we have 500 units. And there's then 10 boxes, if you like, or 10 sub-levels within that. So each one of these smaller lines actually shows us 50 units of output. So I'm just going to put that on there. Always useful to remember at the end, because that way we can work out exactly what these figures mean. Equally on our y-axis, you can see I've gone up, and these are thousands, don't forget. So our major scale there is 2,000, 4,000, 6,000, etc. So each of these boxes, and there's 10 in there, or each of these lines, increments, there's 10 for every 2,000, so each line would demarcate 200 units of pounds. So y-axis increment is £200. Now we can start filling in some of the lines on our break-even chart. I'm going to go through these in order of selling price, variable cost, fixed cost, and then mapping our total cost. Now, on the screen now is a table that you could use to actually demonstrate that. If you're not very confident putting together break-even charts, you might want to use the table. That way mathematically you can work out some of these values at different points. I'm going to explain these as we go through, but this table might be useful to actually help you to map output various levels to help you to plot your graphs. All the lines we're using today are straight lines, and in a future video I'll explain why perhaps there wouldn't be straight lines in real world applications. But all these are straight lines, all we actually need is 2 points to plot them. So the first line we're going to plot is our selling price. And this is going to turn this selling price into our total revenue line. Now total revenue is our selling price times the quantity we're selling. So remember our selling price is £4 per unit. Multiply that by the quantity we're selling, which is our output shown on the bottom, and that will actually give us our plot on the chart. Now the easy way to start is always think about what would be the figures for our lines at output 0. Well, the selling price of £4 is wonderful, but if we sell nothing, our total revenue will be 0. So our total revenue line, always as golden rule, will start at the origin at 0. Now for every one product we sell, we'll make £4 of total revenue. So if my sales were 1, which I can't demonstrate on here, I'd have £4 of sales revenue. If I sold 2, it'd be £8, etc. Now to help us, I said we only need a couple of points. I'm actually going to pick our sales revenue at 2,000 level of output and at 4,000 output to work out where we're going to be. So using this simple formula for our first line, and I'm going to plot our total revenue using a green pen. I've gone for green because it's good. We have the following. So at sales of 0, £4 times 0 is 0. At 2,000 units of output, however, we're selling 2,000 at £4, so our total revenue will be £8,000. So you can see I've actually got that plotted here. So we know we're already at the origin when we sell nothing. If I sell 4,000 units at £4, so 4 times 4,000 is £16,000. So again, I'll plot that point. Hopefully you can already see that's going to create a straight line. Now, unfortunately my ruler isn't particularly long, which is why it's useful to have a couple of different points. And I'm now just going to draw a line here, because each point in between will be accurate to show our sales revenue at that level of output. Do note, try and be as accurate as you can drawing, as we're doing this as a handwritten task. You will find that the more accurate you are, the more accurate your final indication of break-even would be. Final thing I'm going to do is just to mark on that that's our total revenue line. Our next line is going to be variable cost. So this is the cost of producing each item. This one I'm going to mark in red pen. Now this time it's a very similar formula. Our total variable cost is our variable cost, which we said was £1.50, times quantity again. So let's pick 3 points: 0 level of output, 2,000 units and 4,000 units. So the same is true as we have for total revenue at 0 level of output. Variable cost, £1.50 times 0 would mean our total variable cost would be 0. Multiplying anything by 0 leaves us with 0. So our total variable costs equally start at the origin. And let's go to 2,000 units. So this time, variable cost, £1.50 times quantity, 2,000, is actually going to leave us with our total variable cost at £3,000. And one more point, at 4,000 level of output, £1.50 of variable cost times 4,000, which is our quantity, is going to give us £6,000. So you can see once again, we can join these dots together. We only have to plot 2. We've actually got 3 on this diagram, but again that's quite a nice way as a fail-safe. If one of these lines was not on the straight line, we've made an error somewhere. Again, label that as VC. Now you'll notice straight away that the variable cost line, although it starts at the origin, as does total revenue, is a much shallower line. The gradient is far less. This makes sense, as the more we sell of an item, we want the value of that cost to be lower than the revenue. So your total revenue line should always be a much steeper gradient than your variable cost. If it were to be reversed, you'd actually be making a loss on every sale made. British Leyland in the 1950s with the original Mini did just that. So our third line we're going to add is going to be our fixed costs. Now fixed costs are fixed, not because they don't change. Rent is typical fixed costs, and rent goes up over time. It's fixed in relation to output. So we're going to use exactly the same theory, but there's no calculation here. It's very straightforward. So looking at our fixed cost, it's £6,000 per month, and that is completely irrelevant of how much we're producing. Let's say our factory can produce 4,000 units. We pay £6,000 fixed costs. However, if we close for the month, we still have to pay that £6,000. If we sold 2,000 units, we'd still pay £6,000. In fact, at any point here, 2,576 units, I know that my fixed cost is always going to be £6,000. So I'm going to mark that on. Now, if your fixed cost when you calculate it is not a parallel line with the x-axis, you've actually made an error somewhere. So it's nice and easy to see what's happening here. So it's completely parallel with the x-axis, and that's because as output's changing, shown on this x-axis, our fixed costs are flatlining, they're not actually changing. So here we have our first 3 lines. And just incidentally, it's a complete coincidence that £6,000 is the value of both fixed cost and variable cost at 4,000 units of output. You can actually see if they continue, the fixed cost would remain at £6,000, but our variable cost would continue to increase. It's just incidental. We've picked 4,000 units as the end of our graph. Well, that's 3 lines on, and these are 3 important lines. But break-even looks at total revenue equaling total costs. So the one line we're missing is total cost. So let's add that one in. I've picked a purple pen because it's the blend of our fixed cost and our variable costs added together. Many students make the error of calculating total cost and adding total revenue in as well. Of course, revenue is money in, cost is money out, and that's what we're looking for, the total money out. Now, very simple, we're going to add those 2 together, and you may have spotted already the fact that this fixed cost line is completely parallel with our x-axis, means that our total cost will actually just shift the variable cost line up. Well, let's see that in reality and actually see what happens. So we're going to add our costs together. So as a reminder, total cost is total variable cost plus total fixed cost. So let's have a look at this in action. So at 0 output, our total variable cost, if you remember at output 0, our variable cost is £1.50 times 0 is 0, we start at the origin. Our total fixed cost is always £6,000. So 0 plus 6,000 means we're going to start at 6,000. At 2,000 units of output, our fixed cost, remember, stays exactly the same, £6,000. So what's our variable cost? Well, at 2,000 units of output, we calculate our variable cost to be £3,000. £1.50 times 2,000. So to get our total cost, £3,000 plus our fixed cost of 6 takes us to £9,000. And the final point I'm going to plot is at 4,000 units of output. At this point, our total costs are £6,000 for our fixed costs plus £1.50 times 4,000 units, and we've already marked it on 6,000. So 6,000 plus £6,000 leads us to £12,000. So again, we can link these lines together, and if they're not a straight line, we've made an error. So this is our total cost. So we now have the important information for working out break even, and that is our total revenue and our total cost. And remember that break even, the break even point, is when total cost equals total revenue. So that's kind of the condition that we are looking for here. So let's see where that's happening. Well, at zero output, we can see that our total cost is £6,000. Our revenue is 0, so there's a big gap there. But as we follow through, as sales increase, output increases, there comes a point just here where our total revenue and our total cost actually match. We are breaking even. Let's label this. Really good whenever you've got this in an exam to make sure that you are marking these things on there. So break even, one other misconception from students is that it's measured in terms of its monetary value. It's not, it's units of output. So we take this line straight down to our x-axis, and remember these increments. On our x-axis, each increment is 50 units. So 2,500 units is here, 2,450, 2,400 units is the line that we've reached. So our break-even point appears to be 2,440 units. If we sold one more unit, we would make a profit. If we sold one less, we would make a loss. Just to illustrate those, the area that you can see in this triangle shows both our loss here and our profit over there. I'm just going to shade that in just to illustrate. So that area here is loss. And the amount of loss can actually be calculated very simply by looking at the difference between the lines. So if we go to this point here, at sales of 1,500, we can actually see, remember the increments we have here, so that is going to be £200. So we will make a loss of 2,468, 1,000, 2,468, 2,000, and about £200. There might be some inaccuracy with my drawing. So we can actually look at that loss. And as sales increase, obviously our losses decreases until we hit break even. After break even points reach, we have this zone, and this shows our profit. And again, the same is true as with the loss. The larger the gap between those two lines, the larger the profit the business will make. So at 4,000 units of output, our profit would be 2,000, 4,000. So it's a nice quick way of illustrating it. Now if you remember, our business was expecting to produce 3,500 units of output. So this is our current output level. We know that break even is going to be 2,400 units of output. So there's something really useful here to calculate, and that's something called the margin of safety. Now, the margin of safety shows the difference between our current level of output, our expected level of output, and the break-even point. So you can see here that break-even, 2,400, and current output, 3,500, that's a difference of 1,100 units. Now this is called the margin of safety. In real terms, what that means is that we could, if we were aiming at production and our sales being 3,500, we could have sales being up to 1,100 units lower than anticipated or desired, and we would still be in the point where we wouldn't be making a loss. If our sales are 1,101 unit lower, we would actually then be making a loss because we'd be selling 2,399, which of course is below break even. So hopefully that helps. That's break even for you. and in another video I'll show you kind of what happens if our revenues or costs start to shift around.